Today we're going to talk about CGI compositing. You can see by the examples here of the multi-pass renders, and combining them all is what we're going to talk about first. So first, a note about CGI rendering. Rendering time in the CGI world is very expensive because it's time consuming. Okay, so the idea behind it is to avoid bottlenecks by doing as much as possible by the compositors where the workflow is much faster. Okay, so to do this, one of the workarounds is to do multi-pass CGI rendering. And I'm sure you've done this a lot in Cinema 4D already and After Effects, but it just makes a more efficient workflow. Quick changes can be made. So if you think of rendering an entire CGI object, whatever that might be, in one piece, it would be very time consuming and therefore very expensive. And if any changes were made, every time you make a change, you'd have to re-render. So being able to have separate passes and just re-render a single pass is much more efficient, much quicker, and much cheaper to accomplish. Okay, so some types of render passes are what you see here. Okay, so there's everything from shadows, the diffuse pass, which is all the color, and ambient occlusion, which is all the lighting and like the nooks and crannies and things like that. Okay, so it's all these different render passes mixed together to create the full CGI object with all the lighting, with all the shadows, with all the reflections, and with all the highlights as well. So let's talk about some of these passes. The diffuse pass, also known as the beauty or color pass, is kind of the full color render of the CGI object, and it does not usually include specular highlights, shadows, reflections. Those come in other passes, but it will include, of course, all the color, texture maps, and lighting. The specular pass, also known as the highlight pass, just includes the highlights of the object. The reflection pass just includes reflections, so any reflections that are happening on the surfaces in the render would just be in this pass. And the previous pass, the specular pass, and the reflection pass are both comped in using the add operation, so an additive composite mode. Ambient occlusion adds a lot of render time and therefore rendered as its own separate pass. And it's usually rendered as an all-white version of the object with some dark areas. So anything that's black, of course, will be comped out or keyed out. So anything that's white and gray will remain, and that's the lighting that fills in corners, cracks, nooks, and crannies depending on the object. Okay, and this is applied with a multiply operation. The shadow pass is basically an alpha channel pass where all the shadow information appears as white in the render pass and everything else is black, and then it's keyed or masked over top of the image, and it's mostly used in color correction to mix in the shadows so that there's realistic looking lighting in the comp. And then there's the alpha pass, which is just white on black, so the CGI object would appear as white, and then all the black would become the transparency so that it can be comped into live action footage or some other type of background. Lighting passes allow you to render individual lights or groups of lights as separate objects for the CGI. So you can render, as you see in the example there, just the key light and just the fill light as separate passes. And when you're comping them together, you can mix the light however you need to. So you can actually do a full relight in the comp world if you render separate lighting passes like you see here. If you lit everything in the CGI world and rendered it all as one pass, if you wanted to make any lighting changes, you would have to go back to the CGI, make the changes, make any tweaks, and then re-render. In this case, you have full control of just the key light, just the fill light, just the ambient light, and any other lighting variations you might have. And that way, you don't have to go back to CGI to do a full render. Let's talk about render pass workflow. Once all the CGI passes are completed, the workflow for compositing them together can be done in two ways. One's called bottom up, which is basically just mixing all the passes together. And then there's top down, which we're going to look at as an example of soon, is to start with the beauty or the diffuse pass, so that has all the color, lighting, and texture. And then you would add or multiply all of the other passes to it to mix it together and make it look like the finished real comp as if it was rendered out of CGI as one object. Continuing the workflow discussion, some general rules. If a render pass represents light, an additive operation would be used. And if a render pass is lighting information, it is multiplied. So what that means is if you had something like ambient occlusion, which is lighting information, So what that pass is really telling the render is that in these little nooks and crannies or over these little edges, the light's going to fall off this way. So that's not actual light itself, it's lighting information explaining how it's going to fall off into those little cracks. So there's two different things there. So if it represents light, so if it is a light source, you would use an add operation. If it's lighting information, it's a multiply operation. And then if you have any shadow passes, that's, as we discussed, it's used for color correction operations, and it's usually just masked over for that method. So here's an example from the textbook for a top-down composite. So you would start with number 1, which is the diffuse pass, and then global illumination is light. So that's an additive operation, and you can see the result there, in result number 1. And then ambient occlusion is representing light information, so that's a multiply operation, and you can see the result in number 2. And then the third one is reflection, so that again, that's representing light, so that is an add operation. And then self-illumination is the same thing, and it would be comped in with an add operation, and then at the very bottom there you can see the final comp. Arbitrary output variables are render passes which are relatively new to the compositing world, and they are passes that contain scene data rather than light or color information. Okay, so an example would be a depth pass, where it's a pass that has depth information for depth compositing. So it's a grayscale image on a black background, and there's code values applied to each pixel which represent depth. So the whiter the pixel, the closer it is to camera. The darker the pixel, the further it is away from camera. You can use depth passes for effects like adding haze, light fall off, depth of field. So if you have to do camera effects on a comp, then you can use the depth information for things like that. And here you can see a visual example of that. So the original render is bottom left, and then the depth pass. So that's a render of all the deep information. So you can see the closest tip of the plane is pure white, and then it falls off into black beyond that, and that's just depth information. So again, the darker the pixel, the further away it is from camera, and therefore you can apply a depth blur. So the back of the plane is out of focus, the front of the plane is not. The OpenEXR file format is free compositing software. It's the standard in the industry, and it was created by ILM in '99, and it's supported by most software. Nuke supports it, and most 3D apps support it, like Cinema 4D, Maya, etc. And also some editing apps even support it, like Final Cut Pro. So it is kind of a widely used primary file format. Here are just a few important features. It allows tiled images, which is used for CGI texture mapping. And you can also use it supports full stereoscopic, so you can have left and right views for left eye, right eye work. It also supports full rendering and reading of depth compositing. So if you have any depth passes that you need to render out or to read, it will support that. And then it does support full metadata. So any metadata coming from production and then from camera tracking and other departments that get the footage will all be supported. And then you can add metadata as you go too. So you as users and compositors can add any metadata, and it will support all of that and carry it with the rest of the workflow. Let's talk a bit about deep compositing now. It was developed really to limit the amount of complex CGI rendering. Right at the beginning, we talked about how time-consuming CGI rendering is and how expensive it is. Deep compositing are passes you can render out that move some of that work over to the composite department rather than in the CGI department. Deep images are just CGI renders that contain multiple data sets stored within each pixel. At the level of each individual pixel, it can contain more data than what a regular render pass would contain. So if you think of a regular image now, it contains that first level of data, basically. So it has all the RGB information, so that's the color and luminance information. So what hue is that pixel, what's the saturation amount, what's the luminance amount, okay? Second level of data is A, and that carries transparency information, and that's included in depth compositing. And then the third level of data is Z, and depth information. So a regular image without that depth render is just that first level, whereas levels 2 and 3 are added when you render out a depth pass. And we can look at an example here. So this breaks down one image. So if this was just one still frame, one pixel would have the RGB values. it would also have the transparency information, and it would also have the depth information, so how far away that particular pixel is from the camera lens. Set extensions are a staple in the VFX world, and the main reason to do them is to avoid building huge sets. To build massive sets would be really expensive. You'd need a big sound stage to do it, or a big lot, and they're really expensive to build and maintain. So it's easier to shoot on smaller sets or just a piece of a set, and then as the camera moves or as the actors are doing their acting above and around them, the set would be extended, all done through CGI. So this is a typical set extension workflow. The live action is captured on a smaller set, then it would go to the camera tracking department where all the cameras would be tracked. So if there's multiple angles shot of that scene, all of that camera information would be tracked so that it could be applied to the 3D cameras. And so from there it would go in, all that data would go into the 3D department for modeling and animation. And then that would be passed on to the compositing department where they would start to composite it all together. So they would render out all those passes. The compositing department would then comp it all together and light it all and make sure it all matches and looks photorealistic. And here's an example of live action footage shot on a small set and comped in with CGI as a set extension.